All right, let's put on our detective hats for this one. We're about to dive into a case that's a real brain teaser, known as the three-square mystery.
So here's the setup. We've got three suspects, our unknowns, X, Y, and Z. And we've got three equations that tie them all together. Your mission, should you choose to accept it, is to figure out their true identities. This isn't just a math problem, It's a case waiting to be cracked.
Okay, this is our evidence file. Now, at first glance, these clues look pretty similar. But take a closer look. See how clue 1 and clue 2 are practically twins? They've got the same structure, and they both equal 4. But then you get to clue 3. Same form, but it equals 1. That little difference, that asymmetry, that's the first loose thread we need to pull on.
So where do we even begin? Well, a good detective doesn't just start crunching numbers at random. No, the first step is always to study the evidence. We're looking for a pattern, a connection, a weak spot.
And there it is, staring us right in the face. That perfect symmetry between the first two clues, they're like mirror images of each other, right? Just swapping the X and the Y. Whenever you see two pieces of evidence that are this similar, you just know they're begging to be compared. So our first move is an interrogation. We're going to take these two clues, put them head to head, and see what they confess. By subtracting one from the other, we get to do something really neat. Those 4s on the right side just vanish. It's the perfect way to cut through the noise and find a hidden relationship. And just like that, one single elegant move, and we get our first major break in the case. This is that moment in the movie where the detective finds the crucial fingerprint that changes everything.
This is what we found. When you actually do the subtraction, you get a bit of a mess. But with some clever algebraic factoring, it all boils down to this beautiful, simple statement. We've taken a complicated mess and turned it into a product that equals 0. And in the world of mathematics, that is a massive, massive clue. So why is that such a huge clue? It's all because of something called the zero product property. It's a basic rule of the universe. If you multiply two things together and get 0, then one of those things has to be 0. There's no other way. And for our investigation, this is fantastic because it splits our case into two clear, separate paths. So now we've got two solid leads to follow. Our one breakthrough clue has split into two different possibilities. Either that first part is 0, which means x equals y, or that second part is 0, which means x plus y equals 2z. One of these must be true. Now we have to proceed like proper detectives. We can't leave any stone unturned. We've got two leads, and we have to chase down both of them to make sure we find every single possible solution.
All right, let's get organized. We'll start with lead number 1. We're going to assume x is equal to y and see where that takes us. Once we're done there, we'll circle back and check out lead number 2.
Okay, time to investigate lead #1. We take our assumption that x equals y, and we plug it back into our original evidence. Everywhere we see a y, we just replace it with an x. After a bit of cleanup, the whole system collapses down into this one new equation. It looks a little intimidating, I'll admit, but the real question is, can we actually solve it? And the verdict is, it's a dead end. Turns out this particular equation has no solutions that are real numbers. The math just doesn't work. So we can confidently close the file on this lead. It was a red herring, which is actually great news because it means the truth has to be down our other path. All right, let's pivot to our only remaining lead, 2z equals x plus y. We're going to use the same exact method. We can rewrite this as z equals half of x plus y. And when we plug that back into our original clues, things get a whole lot cleaner. We're left with these two much simpler equations. And hey, look at that. They both equal 4. We know exactly what to do now. We subtract them, of course. And the result is just shockingly simple. 9 times x times y equals 0. That's it. This is our second and final breakthrough. The implication is undeniable. Either x has to be 0 or y has to be 0. The case is blown wide open. We are in the end game now. We have a crystal clear path forward. We know for a fact that either x is 0 or y is 0. All we have to do is plug these facts back in, and we can finally identify our suspects. So let's try the first scenario. What if x is 0? If we plug that into our evidence, one of the clues simplifies all the way down to y squared equals 4. Well, that means y can be either 2 or -2. From there, we just use our formula for z to find the last piece, and boom, we've got our first two confirmed solutions. Okay, now for the second scenario. What if y is 0?
Because of that original symmetry in the problem, the logic is exactly the same, just flipped. This time, we find that x squared must be 4, so x is either 2 or -2. We solve for z again, and that gives us our final two solutions. And there we have it. After all that detective work, our investigation has turned up a total of 4 unique sets of solutions that work. The mystery is solved. So here it is, the final verdict. These are the 4 sets of numbers, the 4 triples that solve the 3-square mystery. You can go ahead and plug any of them back into the original clues. They all check out perfectly. Case closed. So, what's the big lesson here? We didn't solve this with some supercomputer or by grinding through pages of algebra. We solved it by being observant. The real key was just noticing that hidden symmetry between the first 2 clues. That one observation cracked the entire problem wide open. And that leaves us with a final thought. We solve this mystery by finding an elegant pattern. It really makes you wonder, doesn't it? How many other complex problems out there, in science, in art, even in our own lives, have an elegant solution just like this one, hiding in plain sight, waiting for someone to notice the pattern?